All right, so let's take a look at the characteristics. This is nothing new. It's just really a review from previous units. I'm just going to show you how to identify specific ones from exponential functions. And the biggest thing, as you probably realized by now, is this line that it seems to have that it goes towards but never touches. Okay, that's called an isotope. Okay, it's a dotted line that the curve gets really close to, it approaches, but it never touches it. This is a listening check. Color in "You shall not pass," circled by the stick. All right, so it gets really close to it but never touches. All right, so when you're looking at our exponential function, this is our general form: y equals a bx. And you may have a number out here, we call that k. So it may look something like this. The important thing to remember is that your y-intercept is, now in previous videos we've always talked about it being a, because in previous videos it's never had a number on the outside. But if it did have a number on the outside, like an adding or subtraction right here, to find the y-intercept you would add a and k together. Okay, so let's find the y-intercept of this one right here, where it crosses the y-axis. You're going to say it's a plus k, which is 2 plus 1, so my y-intercept is 3. All right, my isotope is going to be just k. So if there was no number here, my isotope would be 0. But if there is a number there, that's my isotope. Okay, so my isotope is 1. This is a listening check. Color in y equals 1. Remember, your domain is your x values where the graph exists. In Algebra 1, unless it's a real world situation, your domain is always going to be all real numbers. Okay? Your range is your y values. So let's take a look at some examples. So example 1, you're given a graph. Okay? You're asked to find the domain. So remember, the domain is always going to be what? All real numbers, unless it's a real world problem in Algebra 1. All right, so all real numbers, which means there's a graph all the way on the left. See, from here, there's a graph because this goes on forever. And there's a graph all the way on the right. Because even though this is going up really, really slowly, it's still increasing in the x direction. All right, so I might as well just go fill in all my domains. My domains, all real numbers. Doesn't matter, okay? In Algebra 1, unless it's a real world problem, it's all real numbers, my domain. All right, so when it comes to the range, it's always going to be, because it's going from the bottom to the top, it's always going to either be negative infinity to the isotope or the isotope to positive infinity. Okay, but never including the isotope, because as you can see, it never touches the dotted line. Okay, so I'm actually going to add that to our notes just to make sure that you don't forget it. So it's either, for your range, it's either the isotope to infinity or negative infinity to isotope. But remember, not included. Okay, so those are your two options. So if we take a look at this range, so it's either there's a graph from negative infinity to the isotope, is there? No. Or the isotope to infinity. Is there not? From the isotope to infinity, is there a graph? Yes. So that's the answer. From the isotope to infinity. So it's really important that you know what this isotope is. And remember, to find that isotope, it's really just whatever k is. We can write it in terms of y, it'll be from y is greater, now not equal, greater than whatever this isotope is, which is what? -9. And if it was in an equation, it would be the number over here. Or you can write it as it starts from -9 and it goes to what? Infinity. And then it's very important that you have open parentheses. Why? Because it doesn't include that number. All right, let's take a look at another one for range. So again, we have an equation. We don't have a graph. So remember, it's either from negative infinity to the isotope or the isotope to positive infinity. This is a listening check. Put a box around example 2. If you remember this from our previous notes, right? Remember, these are transformations that happen with any function, you remember that if you have a negative outside, you flip it over the x-axis. So the only thing to remember about the shortcut that I'm teaching you is to check if there's a negative outside. If the negative is outside, this graph, this original graph, is going to be flipped over the x-axis, which means if it's flipped over the x-axis, the graph is from negative infinity to the isotope. If it's not flipped over the x-axis, it's from the isotope to positive infinity. What is the isotope? -2, right? It's the number after the raised to the x. The isotope is y equals -2, okay? Now, is it flipped over the x-intercept? No, because there's no negative, which means the graph looks something like this, like it's above the isotope. So on this one, your range is going to be from the isotope to infinity. So your range is from the isotope, which is -2, to infinity, open parentheses. Or another way you can write that is y is greater than -2. Okay, so it's on the top of -2. If you look right here, here's your isotope. Then you look at, is there a negative? Yes, which means the graph that was above is now been flipped over this way, and now it's what? Below. Which means if it's below, it goes from -infinity to the isotope, which is -3, open parentheses. Or you can say y is less than -3. Okay? Because remember, when you have our original function always looks something like that. Okay? So now, because of this negative, it's going to be flipped over the x-axis. So now it looks something like this, which means there's a graph not above, but below your isotope of -3. Let me put this isotope, that is -3. All right, so you have the isotope is -7, right? And then is there a negative? No, which means it's above the isotope, which means it goes from -7 to infinity. Or another way of saying that is y is greater than -7, not equal to, because it never touches. So let's take a look at end behavior. Okay, end behavior is just what's happening at the end of the graph. As x is going to infinity, what's happening to f of x, and as x is going to -infinity, what's happening to the graph. So you're just looking literally at the end. All right, so in this example, look at as x is going to infinity, as x is going this way, what's the end of the graph do? It's going to infinity. Okay, so as x goes to infinity, f of x is going to infinity. And as x goes to -infinity, as x is going this way, just look at the end of the graph, where is that going? In terms of y, okay? It's stopping, is it going to go below -9? No, because it's going to stop right there. So as x goes to -infinity, f of x goes towards -9. So it goes to -9, but it doesn't touch it. I know that this looks like something like this. And so now you can write it. So as x goes to infinity, okay, so as x is going here, what's happening at the end of this graph? It's going where? To infinity as well. So f of x is also going to infinity. And then as x is going to -infinity, as x is going this way, what's happening to the graph? It's approaching the isotope, which you already know from the previous question is -2. So f of x is going to... This is a listening check, color -2. I know this from the previous question. I know it looks like this. So as x is going, so end behavior is always as x is going to infinity, what's happening to f of x? As x is going to -infinity, what's happening to f of x? Okay, so in this case, okay, because it is flipped, as x is going this way, what's the end of the graph doing? It's going to what? -infinity. As x is going this way, what's happening to the graph? It's going towards the isotope, which was what? -3. In this last example, it's not flipped, which means it's, and if this is the isotope, it's at -7 here, so it looks something like that. As x is going this way, what's happening to the graph? It's going to infinity. As x is going this way, it's going towards the isotope, which is what? -7.